Hi, I'm Travis Elliott with ControlEverything.com, and today we're going to talk about Pocket Chip. Pocket Chip is an accessory for Chip, the world's first $9 computer. If you're not familiar with Chip, you might look it up. It's sort of like a Raspberry Pi. It's a very small computer. It's actually this part on the back here. It's $9, and basically it has Bluetooth, Wi-Fi, it's got a USB port, micro USB for charging, does not have HDMI, but it is a pretty cool little computer. Pocket Chip is this thing here that it's plugged into. Pocket Chip basically gives you a touch screen, which is actually really handy, and a little keypad down here. It's actually surprisingly easy to use. Whenever I first saw it, I thought it was going to be pretty cumbersome, but it's really not too bad. I still set up SSH on the Pocket Chip to do all my terminal-based commands to make things simple, because it can get a little finicky over time messing with the keyboard, although it is usable when need be. So today we're going to actually hook some accessories up to the Pocket Chip from Control Everything. I've got a 4-channel relay controller here, and I've got a SI7020 temperature sensor. And what we're going to do is we're going to use Pocket Chip to display a UI for those devices. I have an on and off button, a quit button, and a temperature readout here on the screen. Now the on-off buttons, as you might expect, turn the relays on and off. So as we can see, if I hit the button on the screen, on, off, and we've got a temperature readout from that sensor. And if you breathe on the sensor, you can see it change. The UI that I went with was actually Tkinter, based on Python. I think Python is really easy to learn language if you're not familiar with programming. If you are familiar with programming, you probably know how to write on Python. Tkinter is a really simple way to use Python to display a user interface. What I also did was I set up the Pocket Chip to boot straight to my Tkinter application. So I don't actually ever see the Pocket Chip desktop. As soon as it boots up, my application is there. It's almost sort of like a kiosk mode. If you were to remove the quit button that I have on here, the user would not actually be able to exit the UI from the touchscreen itself. You would have to cover up the keyboard section because there is a power button down here that the user could use to get out of there. But if you had that covered up and all that was exposed as a screen, you've essentially got a kiosk that the user is not allowed to get out of. And at that point, if you want to exit the application or do anything else, you can do so through SSH. So without further ado, let's get into this and see how it all works. So let's start off with an overview of the hardware that makes all this possible. Now this little board here is the accessory that's actually going to allow you to connect all of your Control Everything peripheral devices to Pocket Chip or Chip. This is simply a I2C adapter. It plugs into Chip and it gives you 2 I2C ports here and here, 1 and 2. These will mount to the Linux image on Chip as I2C port 0 and port 1. So what we would do is we would take Pocket Chip and we would flip it over, and then we would install this on the pins of Pocket Chip. Plug that in just like that. Oh, and before you do that, pro tip, it is easier to install your I2C cable before you do that. So I'm going to connect this to I2C out 1 right here. Plug that in, and then we plug it in. Just be gentle when installing it. There you go. Okay, and now Chip itself, this is actually the $9 computer by itself if you're not familiar. That installs onto these pins. So basically we're sort of sandwiching this I2C adapter board in between Pocket Chip and Chip. Give that a little gentle nudge. There we go. We've got our I2C cable ready to go here. And now we're ready to plug in the relay controller. And today I have, this is actually a photon footprint relay board. Pretty much any Control Everything 4-channel relay board that is either an IoT motherboard, an I2C expansion board, will work for this. I've got the SI adapter here, which basically lets me convert this to a generic I2C device. So what I'll do is I'll take my cable and plug it into I2C in here. Okay, and we'll actually see a power light come on because we're getting power from chip. And then we'll take our second cable and plug that into I2C out down here on the bottom. And then we will connect that to our SI7020 mini module to give us our temperature sensor. Okay, that's all there is to the hardware. Okay, so you should have your hardware all set up and you should have your chip powered up. I also highly recommend that you install SSH on your chip. It is not installed by default. And if you search the chip community, you're actually going to see some information on getting your SSH session to stay open a little bit longer. So that may be useful as well. I use SSH for pretty much everything. I use it for remote configuration of settings in the chip, file permissions modifications. I even upload my files to chip, especially since I'm just making some little Python files and stuff like that. It's really quick and easy to SSH upload files to your chip. So we'll see that now. So first thing I would do is find the IP address of your chip. You can just get on chip's terminal through the Pocket chip and use the terminal right there on Pocket chip and put in IP address show, and that will show you the IP address of your chip. So my chip is actually at 192.168.1.7, so I can go ahead and connect to it now. SSH chip at 192.168.1.7. Default password is chip, and we're logged in. Okay, so the first thing you're going to want to do is whenever you log in, it should put you in the chip directory, which is sort of the home directory. It's going to have desktop, documents, all that stuff. You're going to want to create a directory called PyScripts. This is where we're going to put everything. So if you want to do that, you can say mk directory and then PyScripts. And I do recommend calling it PyScripts because we have a lot of stuff that references this specific directory. So go ahead and hit that to create the directory. Once you've created that directory, we're ready to send some files to that directory. So the files that you need are actually on a GitHub repo here. There'll be a link to this directory on the article. But basically come here, you're going to want to download hello.py and launcher.sh. And once you have those two files downloaded, you're going to go back to your terminal and you're going to simply upload them to the chip. And if you want to use SSH upload like I do, you can do that by entering SCP and then destination and source. I'm actually SSHing the chip right now, so I'm actually going to want to close that connection, so I hit Control D on the Mac to do that. And I'm going to upload a file, so I'm going to say SCP, let's say it's in downloads, and it's a file in there. I haven't actually downloaded the file, but go ahead and put in the download, and then space, and then the directory on the chip you want to put it in, which is 192.168.1.7/home/chip/PyScripts. That's where you want to send it to, and then you would hit enter, and it will take that file you downloaded and upload it to the PyScripts directory. Do that for both hello.py and launcher.sh. I've already got them there, so I'm just not going to do that. So I'm going to go ahead and SSH back into the chip, which you'll need to do as well. And once you're SSH'd back in, we're going to change directory to PyScripts. Hit ls, and you should see both of your files there. We need to change the, we need to make launcher.sh executable. So you're going to want to say sudo chmod 755 launcher.sh. And if you're really good with permissions, you can set that however you want. And hit enter on that. Just give your password, enter your password, which is chip. And now that file is executable. Okay, so if we take a look at that file, and we can actually do it right here. Here's what we got. We got a shebang at the top that tells the executor that this is a shell script file, sh. First thing we have to do is we have to sleep for 30. We have to do that because the display on Pocket Chip isn't ready by the time this launches from cron tab. Then we need to export a variable called display and set it to :0.0. And then as the chip user, we want to launch the Python application hello.py. And that's what this line does. So pretty simple there. Nothing too drastic. This sleep 30, I tried to get rid of it. I couldn't. If you can figure it out, more power to you. And then finally, we need to add this to cron tab, and this is basically what's going to make this application launch as soon as the Pocket Chip boots up. One thing I want to note that's very important: I added a quit button to the application, so you could easily close it. You can always hit the power button or the home button on Pocket Chip to get out of it, so not really that big of a deal. So let's go ahead and add this to cron tab. So to do that, we need to enter sudo cron tab -e. This is going to allow us to edit cron tab. And we're going to want to add this line right here. At reboot sh. And then you can see it's giving the full directory to launcher. And then there's also this line here that logs to a directory called logs. That's what this from right here over does. It just anything that happens whenever that script is being run, any kind of logs or errors will go here. So go ahead and add that line here, and then hit Control Exit and then save. And if you want to, in the PyScripts directory we're already in, you can do make directory logs, and then any kind of errors that happen will get put in that logs directory, so you can check it after boot. That's about it. That's pretty much all that you need to do at this time. After you complete those steps, we can simply reboot. And after you reboot, it should boot straight to that Tkinter UI.